Hi, this is Alex at RF Venue. Today I'll demonstrate wave polarization diversity with our diversity fin antenna using the very popular ULX-D receiver from Shure. Diversity receivers work by choosing the stronger of two signals from two different antennas. Most diversity antenna systems use two antennas spaced a physical distance apart, like the two dipole antennas on this receiver. This is called spatial diversity. Spatial diversity works because the likelihood of a dropout causing null developing over both antennas at the same time is lower than the likelihood of a dropout developing over only one antenna. But spatial diversity isn't the only wave characteristic that a receiver can choose between. Waves coming from a microphone transmitter also have something called polarization. A very simple explanation of polarization is that it describes the way the electric field of the wave is oriented. When the mic is held perpendicular to the ground, the wave leaving the transmitter is said to be vertically polarized. When held sideways, parallel to the ground, the wave is horizontally polarized. The diversity fin uses two different types of antennas, low-gain whips and a higher-gain LPDA, co-located on the same board at right angles to one another. When a diversity receiver chooses between the two signals coming from an attached diversity fin, it's choosing between waves that differ in polarization rather than two signals from two antennas that are spaced physically apart. Let's demonstrate using the ULX-D, which has the LPDA output of the diversity fin connected to the A diversity channel and the whip output of the diversity fin connected to the B channel. Here's the ULX-D switching from one input to the other as the orientation of the microphone is changed. Diversity channel A is the vertical element on the diversity fin, and channel B is the horizontal element. Notice how, even though the two elements of the diversity fin are different types with different gains, the RF level stays the same as the receiver switches from one element type to the other. The ULX-D handles the swap from vertical polarization to horizontal polarization with ease, without dropouts or fades of any kind. Here's the ULX-D set up on our production floor, and me in the background walking around with the microphone held straight up and down. I'm a little out of focus. You can also see the diversity fin slightly beyond the edge of the receiver. Even though the microphone is oriented vertically the entire time, the receiver switches back and forth between channel A and channel B, just like it would with whips attached. That's because the wavefront coming from the transmitter bounces around inside the room and changes its orientation, resulting in polarization at the antenna that changes as the microphone moves around. The diversity fin is exceptionally good at reducing dropouts precisely because it uses polarization variables instead of physical space to deliver two channels with differing signal levels to the receiver. With standard spatial diversity, the chances of dropouts are low, but with the diversity fin, those chances are lower still. In fact, the probability of encountering a common type of dropout called a cross-polarization fade is essentially zero, something no other antenna on the wireless audio market can claim.